Hello, everyone. Thank you for joining our session. Hope the session so far, yesterday and this morning, have been informative and enjoyable. During this parallel session, we have a list of speakers lined up to touch upon an important topic, AI in healthcare. And as you might know, the BDVA, Big Data Value Association, has different task forces and subgroups. Healthcare is one of the subgroups in the application task force. This session is organized to formally launch a white paper written by the member of this subgroup. The paper is published this week, and you can find it in BDVA website. We will share the link as well in the chat. Before we start, I would like to take this opportunity to congratulate the members of the healthcare subgroup who put a lot of effort to publish this white paper. So before we jump into the session, a little bit of housekeeping. All the participants except the speakers are muted by default, and you can ask your questions, but please don't use the chat of Zoom. Instead, use the VOHA Q&A chat session. This session is being recorded at this moment. The other thing we would like to address is we have a poll we would launch. We have introduced a couple of questions. Please feel free to vote using menti.com with the code provided. And if you have any technical issues, please contact the session facilitator, Martina Barbero, email provided here. Here we have several sponsors. Without them, we wouldn't be able to run this session, of course.
I'm very sorry to interrupt you. I'm not sure you're sharing the screen.
I am, sorry. Going to double check. I think I have technical issues here. Maybe I'm going to join again, Martina. Sorry.
Maybe if we have your slides, someone else can share. That would be easier.
Yeah. Yes, it's. I don't see my screen as well. That's.
Maybe one of the other colleagues from the task force has the slides, or I think Tiblet just left.
I could start for now, but if Tiblet could take over later, that would be ideal.
I think she's now back, but it takes a few seconds to Zoom.
All right, let me see what I can do. Okay.
Yeah.
Perfect.
I can see it. Can you hear me?
Yes, we can hear you well, Tiblet.
Yeah, I'm sorry. Sorry that happened. So. I will have to share my screen again for. Yeah, I'm sorry again. Yeah, so coming back. So we have these sponsors. Who made this event possible. And next. So I would like to start with. I'd like to introduce myself. So my name is Tiblet Demeus. I'm a data scientist at Philips Research and also the healthcare subgroup lead within BDVA. We have 6 speakers. First one, Peter van Gorp. He's the program manager of health within the Eindhoven Artificial Intelligence Institute in Eindhoven University of Technology. And Amalia Nemo, a solution architect in Wings ITC Solutions. We have Johan Plomp, a senior scientist and project manager at VTT. Ernestina Menasalvas, professor at Technical University of Madrid. Monica Cabarello, an R&D project manager at Everest. And last but not least, we have Jorge Gonzalez, a director at TIC Biomed. So before we start the session, I would like to launch the pool. So I will try to share my screen again, Peter.
Thank you, Tiblet. I'll wait for that.
Can you stop sharing then?
Okay, let's see, stop share.
Can you see my screen?
Excellent.
Yeah. Yeah, so this is the poll. So we are interested to know about you. If you take a few seconds to put to tell us your affiliation, please go to mentis.com and use code 5579880. Thank you. We have 3 people in, 5, 6. Okay, yeah, it looks like we have more academic people from academia. You can start. You can continue voting if you haven't done yet. So I will switch back to the slides. Peter, I will try to switch back to our slide. All right, then moving on. So this session is organized as follows. So we have Peter, who starts with introduction and comes back with conclusions. And Amalia and Johan will take over to share with us the importance and key areas of AI in healthcare. That's followed by Ernestina, who touched upon the technical and non-technical challenge. Jorge will tell us about enablers, vision, and future potential of AI in healthcare. And the successful use cases will be shared by Monica. As said, Peter comes back with the conclusions. If time permits, we will give the floor for Q&A. We open the floor for Q&A after each of the sessions. We will see how it goes. But in the meantime, please drop your questions in the chat. We will also try to answer them as the session goes on, and also we pick them up during our session and also at the end of the session. So without further ado, I would like to give the floor to Peter. Peter.
Thank you, Tiblet. So the introduction of this session will be handled by myself, and there I will first motivate you why this is such an important topic that we address here. I mean, the fact that we have more than 100 people attending confirms that you already acknowledge that it is an important topic, but we also decided to publish a white paper. So we have indeed additional information on that. So why do we study AI in healthcare? Please proceed. On the one hand, you could argue, well, AI itself is coming everywhere. You have self-driving cars, you've got robots playing soccer, so it's a hot topic, we just publish about it. Now, clearly, that is not a reason to write a white paper. Instead, there's something more going on. AI is also very naturally emerging in healthcare. Now, the remarkable thing there is that high volume of publications comes from the United States. We have a very nice visionary paper here, also reporting already results of AI technologies used in practice in healthcare. Very nice, but to a large extent, US driven, and the European voice is a bit missing there. Next slide, please. Then if we combine that with this publication, which states that there's an inconvenient truth about AI in healthcare, we have to explain that indeed, as Davenport had published, to a minor degree, some specific technologies are already used today in healthcare, but many technologies are demonstrated as a proof of concept in research, but not applied in healthcare. And this has been published in Nature Medicine and also at other venues. Please proceed. In any case, from the European perspective, one would then wonder which technologies, which directions should policymakers invest in? Policymakers that state, okay, big European budgets will be made available for further funding. They have little guidance today on where to put the priorities for future funding schemes dedicated to AI in healthcare, specifically driven by the European opinion. So there is, of course, related work. There are very nice other European institutes out there, and the EIT Health has published this highly influential paper, Transforming Healthcare with AI, the Impact on the Workforce and Organizations. Interestingly, they call for further research. Future research efforts should provide a comprehensive, quantitative view, potentially serving practitioners across all EU member states and across all disciplines and specialties, they state. And that is exactly what we did. But how did we do so? So that's my second part of my introduction. You all know what is the BDVA, and we would argue that the BDVA is the perfect instrument, the perfect organization type to solve this European issue on the policy level that I just described. Because indeed, it's a non-profit organization with a high number of members spreading across Europe, balancing well large and small enterprises, research institutes, universities, and user organizations such as hospitals. So it's pretty natural that from the BDVA, we launched this initiative to reach out to our European community and address this problem that I sketched. And we did so in a way that we collaboratively have been writing this white paper, where the various members were represented in this task force with a focus on healthcare. Now, the white paper is based on 3 research methods. For one, it has up to 70 citations of other work. So clearly, we look very carefully at what has already been published in this domain. Second, we have performed a survey where we received 131 responses. Wondering about the participant distribution, here's an answer. Just like with the session today, there was a high representation by academic institutes. So if you look at the detailed chart, you see 52% of academic affiliations. And then the green part is industry or standards organization, and large enterprises are in yellow, SMEs with 15% in red. So far for the survey. Then we organized a large workshop in 2019, September, where we had also good representation of the target audience. Over there, it was better distributed in the sense that there was less than half of research institutes. And we have also a good representation of industry in yellow here. And then a reasonable representation of hospitals, 1 in 4. In the reflection of our results will indicate that ideally we would like to increase that, but this is what we managed to realize in the basis for this white paper. Yes, then we move on. Okay, the next will be Johan and Amalia speaking about one topic addressed both in the survey and in this workshop, an answer to the question, what is the importance of AI in healthcare and which are the key areas? Thank you.
Thank you, Peter. So perhaps maybe you can have a quick look if we have any question from the audience, important one for you. If not, then we proceed to the...
I would also indeed like to stress that besides questions, any comment is very welcome in the chat. We happily handle them there offline. It's, in my view, an excellent opportunity that we're now in this online setting where we can even have more interaction than in the past. So please do leverage it, and we will certainly look at your comments over there. Thank you.
Okay, thank you again, Peter. So if there are any questions, then of course we will take them also at the end. So now I would like to give the floor to Amalia and Johan. Amalia and Johan, yeah, they will talk about the importance and key areas of AI in healthcare. The floor is yours, Amalia. She will be starting.
Thank you very much, Stiglitz. Thank you very much, Peter, for the nice introduction. This is Amalia Demo, and I am going to be speaking to you today about the importance of AI in healthcare. We can move on to the next slide, please. Thanks. There is no doubt that AI is touching every sphere of our lives, especially in the healthcare domain. Its impact is significant on patients, clinicians, pharmaceutical industry, and others. There are obvious benefits from AI specializations like radiology, pathology, ophthalmology, and cardiology. It contributes to economic growth and well-being as well. In the United States, healthcare expenditures reached to $3.5 trillion, while in Europe it is 0.4 trillion, which corresponds to 18% and 11.5% of the overall GDP, respectively. While in 2021, jointly public and private sector investment in healthcare is expected to reach $6.6 billion. Next slide, please. Thanks. AI is being used for a wide variety of healthcare applications, virtual assistants for healthcare professionals, over automated processes in image diagnosis are indicative examples. The implementation of AI-based clinical decision support systems has become more and more attractive for healthcare professionals, clinicians, caregivers, health authorities, etc. Different technologies based on knowledge and learning has been widely used to strengthen these systems. Better understanding of medical processes is provided by AI as well, where and when humans are not able to handle due to the complexity, the nature and the volume of data. The combination of robotic technologies with AI is also very promising and challenging. Automatic distribution of packs, or on the other hand, disinfection, care and socially assistive robots have already been parts of hospitals today, especially these days due to the pandemic crisis. Moreover, faster implementation of algorithms and better predictive models have improved healthcare operations. Going further to the next slide, and the survey question, which is related to the impact. So more specifically, the participants in the survey were asked what is the expected impact and value of AI in healthcare, and what are the benefits and outcomes generated from it. Let's now look at the next slide, which shows the results of the survey. Most of the participants believe that AI is contributing factor to the reduction of the healthcare costs and the improvement of quality of life and well-being of patients. With very little differences, almost equal number of participants believe that insights and knowledge from data as well as decision-making processes can also be significantly impacted by AI. A great number of volunteers argued that through AI, the outcome of patients is improving, as well as predictive models show improvements. Then come data-driven perception and reasoning as additional benefits of AI. About 12 participants from the audience supported that AI systems offer early health risk recognition and predictions, and fewer went for the improvement of quality of life of healthcare professionals. Topics that were identified as less important was data understanding, augmented AI for healthcare, and understanding of medical processes. It is also interesting that there was only one vote for other impacts and one for faster implementation of algorithms in this sample. With this slide, I close my presentation. Thank you very much, and I will now give the floor to Johan Plomb, who will speak about the key areas of AI. Thank you.
Thank you, Amalia. Yes, so next we set out to give an overview of the key areas which are have the most opportunities for applying AI in healthcare. And in order to do so, we set out to make a categorization of the key areas. And that was facilitated by first defining 3 dimensions that define this categorization. The first being the actors, and the second, the health continuum phase, and the third one, the objectives. And in addition to that, we identified a number of enablers that are effective across the whole area, but are in some cases also themselves key areas. Next slide, please. So this Penrose triangle indicates that these 3 dimensions actually are of course separate from each other, axes that define this category. In total we have that means 27 key areas defined by these 3 dimensions. And if we look at the dimensions, the first dimension is the actor. Starting with the person, and of course we are thinking person-centric, so that's why also this person is there in the middle. The person who after diagnosis would usually be the patient, but we want to look at a broader field here. And before the person becomes a patient, he is just healthy and at risk. But another actor here is then the health service provider, and with that we mean really a broad sense of health services. So providing the health services to that person, typically in the case of healthcare, but it may be also broader than that. Then we have policymakers, so those who make decisions actually about how to use the resources that are available, and that's of course may mean the politicians and the population health programs, but it also indicates, for example, the management of a hospital or insurance companies. Then the second dimension is the health continuum phase, and this is perhaps the dimension that is most used to indicate the key areas. We have diminished the number of steps that you usually see in the health continuum phase to make it a bit easier to handle. So first we have the healthy and at risk phase, where a person has not received any diagnosis yet. So that means he is not a patient, but at that stage he might know something about the risks that he has. Then the acute care. So whenever the health condition deteriorates in such a way that it's clear that there is a disease, then we enter this acute care phase, where a diagnosis would then, please don't continue yet, where the diagnosis would actually then be done, and planning for the interventions, and then of course the interventions as well that aim to cure a patient. If that happens and it works out well, then of course the person is actually returning to the healthy and at risk phase. But in some cases we have chronic diseases or other conditions that need longer term care, and that's when we enter the chronic phase, the chronic care phase. So that includes also, for example, the elderly care and usual care of chronic diseases, and rehabilitation and prehabilitation. Then the third dimension is the objective, and you could perhaps see that best as being a part of this health continuum phase. So in each of these phases, what's actually needed is that we have to measure first. We have to understand the health condition. That's this first part. Then the second part is that we have to plan how we will act upon this knowledge that we have achieved by means of this measuring. So from the diagnosis, we make a care plan or a treatment plan. And finally, then the intervention objective means that we actually carry out what we have been planning. So that means, for example, the medical intervention, but it can also be the care given to the person, or a population health program being launched by the politicians. Yes, now you can go to the next one. So when we look at these key areas, we end up with 27 different key areas that we can identify, and they are given in our white paper. I won't go into much detail here because it takes too much time, but one of the things that we try to map on this is also the outcome of the workshop results, and the bolded topics that you can see here are the ones with the number behind it that indicates the interest that it received, or the importance that was perceived in the workshop. So for example here, please go back to the previous one still, the healthy at risk phase. You see that here self-monitoring wearables are perceived as rather important key area with a lot of opportunity, and preventive care here is taking an important place. Next slide, please. And if we look at the acute care phase, then we see that especially in the planning part, we find traditional decision support to physicians for diagnostics and personalized medical care receiving a lot of attention as an opportunity for AI in health, and also the traditional domain of medical image processing, where of course AI has been applied already for a very long time. But also on the policymaker side, you see here that the population health and chronic diseases now also with the COVID situation is becoming more and more important. Next one, please. And here you see from the chronic care side that the intervention specifically for people by means of self-care, remote care, or assisted living received some attention also from the attendees of the workshop. Then the enablers, we should not forget about those, because they are of course pervasive throughout the whole areas. And we see here, for example, that we have the health information management data is of course what we drive all the developments in AI with. So that is a very important part, and the availability of data is really an important factor, enabler for this whole field. Same as with health organization, so how healthcare is actually organized. And finally, also the health and technology research, which is more and more not just, let's say, providing new innovations, but also themselves needing AI for doing actually the research. So it's a key area as such as well. Yes, please, next. This is an overview of the survey. I went through the results already partially, but you can see here indeed that the traditional area, I would say, of diagnostic support to physicians, personalized medical care, medical image processing, they are really the leading areas still. But then there are new areas coming up like preventive health and population health, chronic diseases, which give new opportunities for AI in healthcare as well. Next, please. And similarly, the workshop that was organized by the Big Analytics project actually confirmed these findings. So also here you see a similar kind of ranking. Next one. So as a conclusion for the key areas here, what you can see is a list of the most important things that we found. The diagnostics and treatment planning, preventive care, personal diagnostics, health coaching, healthcare optimization, medical image processing, remote care and assisted living, health information management, population health and chronic diseases. And that concludes the key area overview.
Thank you, Johan. So yeah, so far I don't think we see any questions. So I think we keep all the question and answer for the end of the session. So I would like to move on to the next section. We have Ernestina who will talk about technical and non-technical challenge. Ernestina, the floor is yours.
Thank you. So, okay. So we are going to talk about the technical and non-technical challenges, and we are going to start. Next, please. Okay, we will start with the technical challenges. Next, please. And well, when we start talking about the technical challenges, next, please. Okay, the main thing that we can see in the literature is that the main thing in which all the challenges that we are facing today and in the latest period since AI reached the healthcare sector is the presence of multiple data sources. The thing is that in the healthcare sector, we have the data that we get from the consultations, we get the data that we have in the monitoring in hospital, but also the monitoring outside hospital, that this can be in smart devices or in all devices that traditionally has been just taken in home care. So this is producing multiple kind of heterogeneous data. This data can be that is some of these can be structured information, but most of this data will be non-structured data that can be starting from images. And in the images, we will have the thing that different images will be recorded by different machines, different devices. We will also have that we will have clinical narratives, and this will be just written in different, it will be multilinguality problem or challenge, because we will have, well, text written in Spanish, text written in English, text written in any of the languages of the countries in which the hospital or the healthcare system is located. Then we will have also the data that has to do with signaling, with all this data that is real-time data that we are getting from the UCIs, for example. And then we are also having, well, just to mention but a few, we have also the genomic data, we have the lab tests, and what happens is that all this data is not only news that we have all these different formattings, but the thing is that depending on the device, on the lab, on in which place they have been taken, we will have just the challenge of integrating to them. So the main challenges from the technical point of view that this data has is on the first hand, the availability of the data. First of all, we have that, well, we will be able to access, and this will not be a problem, or this is where data security will come. All the problems of data protection that we will see later will come on the data of one particular hospital. But when it will come just to integrate data from different hospitals that comes from different countries, then it is just not a problem of interoperability. It's not a technical problem, but it comes that is a legal problem, because what we have is that the legal issues will not allow just to flow data from one country to the other. Then once we have, apart from the problems that in this sense, we will have solutions that will be, for example, federated machine learning, just to deal with this solution in the literature. But also we have all the problems dealing with the data integration. Thus, as we have all this heterogeneous data coming from different devices, we know all the time and all the solutions that are required prior to applying AI to the data. Because we all know and this is what the literature is all full of, all papers just dealing with data curation issues, and in the pipeline, how trying in this democratization of data, how to try to clean all this data, to curate all this data, because finally we have to trust the data. And if we are going to apply machine learning algorithms, AI algorithms to extract the value will be valuable in such a case that the data has been properly integrated and that has been properly curated. In this point is where we will have that finally we have all the solution that has to do also standardization, that it plays a crucial role, because despite of the interoperability issues, for sure that we will have standardization, and of course data privacy. Next, please. And then we were asking, now that we have made all this review of all the challenges that we have in the literature, we were asking in this survey that we have been mentioning, which are the critical data sources for this availability of data, which are the critical sources that all the people present in the survey were thinking that we have. Next, please. And if we analyze the results that we got from the survey, we can see that 30% of the people were saying that one of the critical data sources is the access to electronic health records of the patient. This is very interesting, together with the data that is being generated by the patient. This is what we were mentioning, that is all the data that can be just from monitoring at home, not necessarily at the hospital. And then we have, of course, the access to medical images. So this is just the critical data sources. But next, please, we also were asking in the survey, which are the technical challenges that the people thought that were the most important, just to see if it was according to the literature or not. Next, please. So we can see, yes, sorry, that the main issue that the respondents were seeing is that data security and anonymization is one of the issues. This has to do with this that we were saying, also that has to do with the legal aspect, that how we access to the data that are in different hospitals, and then the privacy issue and the anonymization issues that we have with the data. The other thing that we have is this data availability that we were just mentioning in the literature, together with large and rich label data. We have to remember that we are going to apply machine learning algorithms and that we are going to apply solutions that will be supervised. And for this, we will need corpus that are annotated, data that has been annotated, so on and so forth. And for sure, the following one, it will be data quality and curation. Next, please. Okay, so finally, just as a conclusion, what we have to see in the technical side is that we have heterogeneous data sources that has to be integrated, and that the main issue is the data quality. So we have just like the main studies, the data quality, that we need accuracy when curating and the data, and for this we need to develop infrastructure and technologies that provide the necessary protection to host and store the health data. So if we continue, next please, with non-technical data issues, then the thing is that when we go for non-technical challenges, the thing is that, well, always when we have technology into any domain, we have just issues that has to do also with the non-technical issues, social issues that can arise. But in the case of healthcare, this is especially important because the final person, the final recipient of the solution will be the patient, will be the person. So the first thing that we have, and maybe the first regulatory issue that will come into scene, it will be the protection. Protection that has to do with data and that has to do with devices, okay? So the first thing that we have to protect is devices. And when we are talking about devices, we are talking about from the largest device that we can say, these big supercomputers that they can host all the data in one hospital or in one country, all the data that they have of the health system, to the small devices that we have, a small watch that is just recording our vital signs or whatever. Okay, so also we will have to take care of the data, and it's not just protecting the raw data, the data that is being produced when we take an image, when we talk to the doctor, but also when we aggregate this data, when we analyze this data, and when we produce results out of this data, and this has to be protected. This goes next, please, to something that is just dealing with the data sovereignty. This is something that is important, that has to do, is something that has to be regulated, and is regulated in each country. And all the countries in the European Union has to say and just establish regulation regarding who's the owner of the data. Next, please. And despite that, the General Data Protection Regulation will go, that has just helped a lot, and in the last years, because all the fines that has been taken just for the bad use of data is helping a lot. In any case, we have just to regulate all this data, sovereignty, just to know who's the owner of this data. And this goes also just together with ethics, because the thing is that we have to be just how using the data is ethical or not when we are using. We will deal later on the ethical aspect. Next, please. So the other thing that we have to do, and that is important just always to mention in the regulatory aspects, has to do with standardizations, because this is something that when the technology jumps into action, standardization will help. In a sense, standardization is going to boost in the way in which we are producing the technology, and it's always to regulate. I mean, because one of the main challenges that we have now in applying AI in healthcare is the lack of standards just to decide on all the aspects regarding to the use of the data and the use of the models in the data health. Despite of interoperability standards like HL, for example, that this is just should be used, for example, or RESTful APIs and so on, because they are following the FAIR principles, and this is important. All the interest that the standardization is growing in a sense is having that. I mean, it has been just arose in the ISO, and we have more than the ISO 42 is just producing more than 14 standards to deal with the data availability, data management, and in general AI on data. So this is just something that is really an important aspect. Yes, next please. So just going to ethics, that this is something that, as we were saying, this is something very important, that because I mean, we were saying that the final recipient of the models will be the user. And this is something we have to deal with, because I mean, the data comes from the user or from the patient, and the decision-taking process that is going to be taken will just take into account the user. So the thing that we have to see here when talking about ethics, and that's why so much analysis and papers and publications we are having in the literature, has to do with which is the final responsibility of applying certain models. Because if someone applies a model decision in a hospital and finally someone dies, who's the responsibility? The responsibility is the doctor taking the decision. The responsibility is who just produced the model and the set in the dashboard, or it is who took the data, who applied the model, who took the model. So this is something that we have to take into account, and this is very important. Next, please. So we have something that something that it is we have seen in companies that is ethical by design. This is just something that has not to do only with just dealing with if certain data are private or not, if we can produce certain models or not, but just has to do from the general, I mean, perspective when we are generating our models, that we have just from the very first design, just to start thinking on how it affects or we can spot some ethical issues. And that's why this is something that also has to take into account. Next, please. And then, well, now that we have reviewed all the things in the literature, we have asked this also in the survey, and then we asked which are the non-technical challenges, and the main responses we can see in the next slide is that, as we can see, 30% of the people were saying that regulatory challenges and the lack of policy was the main worry. This is something that agrees what we have been just analyzing that is on the literature. The second one was really regarding privacy and data protection. This is something that we have said that because the individual is there and the data and devices has to be protected. And then something that is very important and that has to do with ethics is the user acceptance and the public opinion and ethical and societal acceptance of the solutions that will be producing. This is very interesting from the point of view of the agreement with the literature. Next, please. So, well, just to end up, the conclusion is that we have like a balance. So if we were thinking that maybe just in the application of AI in healthcare was mainly the technical issues that we're just gaining, and that in order to have solution, we have to put a lot of stress into technical issues. This is true, but we have to take into account the non-technical issues, because we have the paradox that we have here is that the social and ethical implications of the use of the technologies are delaying the great social value that AI may bring into the sector. So that's why we have to work on these regulations the sooner, so not to stop that all the things that we are producing in technology, that they can go to society and they can go in the proper way. So thank you.
Thank you, Ernestina. Very interesting. So I think maybe I suggest to have some time for Q&A. Peter, do you see any question coming? Or I would also like to invite the participants to pose their questions.
I would also certainly recommend everyone to keep on posting questions, but we certainly have two. One of them I have copied from the chat to the session Q&A, and that was by Leah Rifi, asking, can you give examples of AI-based healthcare assistant, please? On which in the chat, we had already a brief reply stating, wait, it will come later, but perhaps indeed it can be handled now intermediately, briefly, also by Monica.
Yeah, hello. Yeah, oh, my screen doesn't, well, using mine.
Yeah.
My background has failed. I will switch it. But meanwhile, let me, oops, sorry, let me go for it. So the idea, as I will be presenting afterwards, the oops, sorry for this. Oops. So I will be presenting afterwards the use cases, but as I introduced also in the chat, one of the use cases is addressing the it's a self-monitoring system. So in part, it can be seen as an assistant for the health. I mean, AI is being used as to provide hints and to the patient, to the user of their health status. I don't want to spoil my own one, but I think in some of the success case draft today, you can see some of them. Otherwise, today I'm just going to go through some of the selected use cases, but there are a lot of other projects and more information in the white paper that can be checked, but for sure there are some.
I sense you don't want to give away your spoiler, as you say, so let me then give an additional example.
Perfect.
In the Netherlands, there is, for example, a startup called emmazorgt.nl, which is emmacares.nl. I mean, don't write a URL because that's the translation. And in a nutshell, they really take this notion of an assistant quite literally, in the sense that there they make use of smart speakers to really offer remote assistance, but also remote surveillance in a way. Specifically looking at the human-computer interface, where often elder lack good means to interact with a tablet even, let alone a smartphone. So then when an elder would say, Emma, when did I take my medication or so? This digital assistant should be able to help. This is all work in progress, and indeed, it's still in the research phase to validate such instruments in practice. But then I think also to answer your question well, the table that was presented by Johan is really of great help. And I recommend you all to look again at that in the white paper as it's published. So over there, you notice that indeed you have multiple stakeholders. And the example I've just given is one that is directly aimed at the patient and also the informal caregivers around that patient. So in this example, when you would tell the smart speaker to get help, also the family members would receive a notification in the smartphone application or potentially be called and so on. But then the table that Johan presented clarifies that, of course, also beyond the home setting, there are possibilities for smart assistants in interventional settings, where you may have noticed indeed even augmented reality in intervention settings. So where a surgeon gets indication on where tumors might be during a surgery. So those are, again, rather visionary examples, especially thinking of the augmented reality. But what is not science fiction at all is the whole AI underneath the computer vision, where in the past it was all about offline analyses of individual images, but increasingly you see successful use cases where the interpretation is done in real time. Okay.
Perfect. Thanks, Peter. Do you have maybe one question quickly, and then we can move on to the next section? No? Okay. If not, then yeah. So let's move on. Then we have next Jorge who will talk about enablers, vision, and potential of AI in healthcare. Jorge, the floor is yours.
Thank you very much. Tibbles, can you please move to the next slide?
Yeah, of course.
So in that survey, we also asked about the enablers, and you can see there the results. We are going to mainly focus in the top 4. As you can see, there is a kind of a natural clustering on the top 4, where we can see, next slide, Tiblets, that the basic 4 enablers are open anonymized medical data repositories. So what we can see from the survey, and also from other initiatives that there was an event and the results were very much alike, is that there is a kind of craving for data. I mean, especially for the people outside the healthcare system, their problem is to reach the data. Give me the data, I want to do something with it, I know it's going to be good, but there is no access to that data. So there is a kind of 2 worlds: the people that have the data, the healthcare organizations in our case, and the people that can the capacity to do data, but seems that they are not very well connected. So that's why they are asking for open anonymized medical data repositories as an enabler to proceed, especially their research, as mainly the respondents to that survey and the people participating in the event, they were coming from academia. Now, the next enabler that I see, that, no, if you can go to the previous one, is that there is still a need, and it has been one of the questions now to okay, but show me the value. Okay, where is the value at the scale that artificial intelligence is promising, and how we can really assess if that value is worthy or not. So there is a kind of suggestion that there is a need for large-scale pilots that exemplify the value of artificial intelligence in solving concrete examples of in healthcare organizations. Now, if you're familiar with healthcare, if you are familiar with doctors, and you have been working with doctors for a while, it's not always so easy for a machine to tell them what they have to do, right? So there is a kind of, especially in healthcare, probably in other sectors, but in particular in healthcare, seems to be very important that having why the machine is making this recommendation, in the case of this algorithm is doing that, explain why they are coming to that conclusion seems to be something that is important in this area. And of course, the inclusion of key stakeholders for doing all of the above is very critical. So if you go to the next slide, Tiblets, then it will be no surprise that we are basically focused on the same as our own recommendations. Okay, of course, there is a need for accessing data for the researchers and even for the startups, the companies, the big companies that they want to apply artificial intelligence for healthcare. There is a need to foster large-scale pilots. As you may know, there are a number of them funded at European, national, and regional levels, but it seems that there are not enough. And actually, by the questions we are getting, I think this is true. Obviously, this needs to be done with a better communication with the key stakeholders. In our case, those managing the data or owning the data. Ownership is always from the patient, but at the end of the day, the ones that manage the data is kind of the owner of the data, and these managers of the data, most of European countries, 80% or more is on public hands. They are very reluctant to share the data, okay, as in a straightforward way on this. So there is a need to what we see is to have a dialogue between the data managers / owners with the people that have the capabilities to do something productive with that data. For that, obviously, trust is a must. Okay, it's not easy. I mean, at least from my experience, even within the same healthcare organization, people have a lot of hurdles to access the data. Okay, so if that is going to be shared with an external organization, the hurdles are going to be much higher. And if there is no trust, there is nothing. Okay, healthcare is not fast, so it's very easy to delay things and make things not to happen if there is no trust. So this is not easy to be done. It requires time and requires connections. I mean, in terms of doing things together and really seeing that things can be done without harming that trust on, for example, in privacy, security, etc. And this needs to be done, of course, by promoting also open repositories, but especially by fostering interactions like in large-scale pilots. I personally hate the word pilot. I would prefer the word projects, okay? Because what is important is not the pilot, if the pilot is successful, but that the project, the escalation of that a successful pilot, the implementation of that pilot is successful. And again, as perhaps a particular angle in healthcare is explainable AI, XAI, as we call it also in the previous slide, is very critical, very important for this sector. That's all from my side, triplets.
Thank you, Jurgen. So I suggest we go to the next session and we take the questions at the end. So next we have Monica, who will share the successful use cases. Yeah, on the earlier question, she has, she wanted to combine maybe also your question, the earlier question together, right, Monica? Go ahead.
Yeah, so if you can go, you come down to this, perfect. Yeah, thank you. So yes, I'm Monica, and I come from Everest. And in this section, I will do my best to sum up the variety of success use cases that were introduced in the white paper. There is a lot of projects and initiatives dealing with the application of AI to the healthcare sector, and to reduce and narrow a little. In this white paper, we made a selection among European funded projects from the EBDVF community. Our aim was to cover the key areas introduced in the white paper, presenting solutions addressing from the prevention to the care stages, and also addressing different kind of actors, as Johan explained, the patient, the health professional, and even the healthcare solution provider, health data scientists and researchers, and not included in the slide, but also policymakers. The use cases that we selected belong to 3 projects at different maturity stage. Those are the EUROSIS project, the Big Metalytics project, and the Deep Health project. And I will provide an overview of the use cases from the 2 first ones and go a little more detail on Deep Health, which personally I'm involved since I'm the project coordinator. So in the first use case from the EUROSIS project, this project is already finished, and it consists, the use case consists on a decision support tool for improving the treatment of HIV patients. Thus is a use case addressing the health professionals. This project created, developed a prediction engine, the EUROSIS prediction engine, which is publicly available since 2008 at their website. And it was one of the first AI-based solutions for the optimal selection of antiretroviral drugs for HIV patients. In order to create the engine, this project also creates an integrated database coming from real clinical practice that currently counts with more than 100,000 patients from Europe, Russia, and Africa. So it's even the project is over. The initiative still continues, and you can check in their website. This engine was compared also with other state-of-the-art tools available at the moment, and also compared to the performance of experts and provide very good results. As you can see here, also there is an article about it. And just to provide some figure, it gives the correct outcome in 76% of the cases. So next one, the next set of, thank you. The second set of use cases come from the Big Metalytics project. I'm sure you know also, you're aware of this big project. It implements 12 pilots covering all major disease groups in Europe and all the stages in the healthcare continuum. So, and as such, you can imagine it addresses a wide spectrum of challenges that have been commented in the previous talks of my colleagues. And most important, it proposes solutions for them. In the white paper, we select 3 representative pilots from this project. The first one is the radiology workflows, which is a good example of the use of AI for supporting the diagnosis. In this case, the pilot provides an efficient search engine based on natural language processing for searching in large databases of radiological data. And so the radiologists can check one case and find comparable cases. So that allows them to improve the response time and the quality of the diagnosis. The second pilot selected and use case is the kidney disease that supports the clinical staff to treat the patients before and after a kidney transplant. In this case, the system monitors the adherence of outpatients and predicts using machine learning possible risks, for example, of rejection of the transplant. And the last one is the stroke management pilot that shows how to use AI to optimize workflows within a hospital and thus reduce unnecessary delays and bottlenecks. This use case can be also, can reply also a question that has been posed about how to imagine the digital twin applied to healthcare. So in this case, we can imagine creating a digital twin. I'm not 100% sure if this is the technology used in this pilot, but it's straightforward to deduce that given all the streams of data available of the patients, how the different workflows at the hospital, you can model you can create a digital twin of all the processes at the hospital, of the workflows, and use it to model and to simulate how to reduce this any delay or optimize the different stages in the care of the strokes. And I want to also mention within this project an output which is not a use case, but can be seen as such, is the blueprint that they have produced, including best practices on the use of big data and AI in healthcare. And they complement it with analysis and comparison of the different technologies and solutions that can be applied. So next one, please. The third set of use cases come from the DeepHealth project. DeepHealth is a project that aims to reduce the current gap between the availability of mature technologies and AI, but also in HPC and cloud, and the gap with their deployment in real scenarios. Here, the focus is on exploiting the convergence of AI with HPC and cloud for the analysis of large and complex biomedical data sets. This was one of the challenges, and focusing on imaging biomedical data sets. That's also commented today. DeepHealth provides 2 different kinds of success use case. On one hand, it provides a free and open source software that's European technology, which is a very good asset in a current ecosystem of tools and toolkits led by United States and Asia. And this toolkit allows to, and it aims to boost the development of another solutions based on AI for the healthcare domain. But not just that, because DeepHealth is also developing large-scale pilots as an examples. So we just heard from Jorge that was one of the main enablers, and in a way to validate this toolkit. So we have 14 use cases in 3 domain areas, and building that sets up in different kind of test beds. Let me go a little detail on the toolkit. It's composed of 2 libraries, one from deep learning functionalities and one from computer vision functionalities, and a backend and the front end to use the use both by data scientists and health researchers, and provides a unifying framework offering the deep learning and computer vision capabilities that are completely adapted to exploit, to use any underlying architecture, or HPC, big data, or cloud architecture. The toolkit, then, it's addressing some of the implementation challenges identified in the session today. It reduces the complexity to create easily applications based on AI, since it's straightforward to use it in any software platform or application, an existing application. And it increases the productivity of the developers of these applications, since it optimizes the training of predictive models that nurture the applications. Furthermore, and I think this is also important, it allows to do it so with a profound knowledge of all these technologies, meaning AI, HPC, big data, cloud, which is important. You can have an expert on AI, but not an expert on developing specific solutions for health. So it reduces the need of highly skilled personnel, and it allows to do it, to develop more easily. And regarding the specific use cases, for the sake of variety, we select those two of them that differ substantially from the rest of the use cases that EUREC's topic modalities presented. So next one. The first one, and this is what I was mentioning before, it's focused on a disease management tool for addressing patient lifestyle and improve daily living. So here we are looking at a self-monitoring system. First version addressing the prediction of migraines, and it's based on a mobile app, which is called MigraineNet. It's developed by WINS, and it's a cloud-based mobile service that provides, as I say, the personalized healthcare solution, or it can be seen as a healthcare assistant for people who suffer from migraines. So the user can, as you can see in this slide, some of the snapshots of the app. You can introduce some data, and it can help you to identify if it's a migraine and how to improve how you are dealing with it. Within this use case, it's also being developed a solution for non-hospitalized epileptic patients who would like to better monitor the seizures. And in this case, the system collects data both from the mobile app, but also from wearable devices, and apply machine learning to detect any initial patterns before an episode, and immediately notifies the caregivers, triggering an alarm. So in this case, it's not just for the patient, it's also for the carer, or the career, sorry. And this system is also being explored to use it as a tool for people who suffer from depression symptoms. And in this case, the idea is to predict the progression of the depression symptoms and detect events that can cause the symptoms. So in order to inform the doctor, so they say they can provide better recommendations to the patient on what the user or the patient should do or should avoid. And next one, please. Finally, the last use case, predicted a population model for Alzheimer's disease using structural neuroimaging, was selected as a good example of exploiting the rich information that most public health systems have of large data sets of biomedical images, in this case for increasing the disease knowledge and for investigating new avenues for the advance of public health services. In this case, the focus is on the study on which areas of the brain produce the possible variability between healthy and pathological subjects. The idea is to develop populational models on how the volumetric degeneration of the gray matter happens due to the Alzheimer's disease. So they are correlating measures of the brain surface areas, which are identified and segmented with the help of predictive models and AI. And they correlate with features such as age, gender, the geographical area, and of course the pathology. So they can identify, for example, how the geographical area affects the evolution of the disease. At the end, the idea is to, from this model, to be able to extract indicators that can be used to assess the health status of an individual and develop a decision support system. So that's everything from my side. I don't know, Tiblet, if some questions have arise about it.
Peter, so Peter is checking. So Peter, do you see any question coming for Monica? Also for Jorke and the others?
Specifically for Monica, I didn't see an additional question. In fact, the one on the assistance was one that came too early, but now no extra questions. We do have a question that is related to a previous question, a previous section in the talk, so the one by Johan, asking basically for some clarification or example on digital twinning.
Yes. Well, I can say here, but I don't know if Johan would like to add some more, that I just commented in one of the use cases from the big Medalytics, that the management of the workflows can be a very good usage of a digital twin to improve healthcare. But there's also initiatives making applying the digital twin concept to the patient directly. So creating a digital twin of the patient, so you can simulate treatments or any other action to the patient itself. So those for me are the two different kind of ways of applying the digital twin concept to the healthcare sector. I don't know if Johan, you would like to add some more here.
I guess that's a good example. If I have to dig from examples from VTT, then I know that we have been doing quite a lot of work on the profiling of people, and that means also the profiling of their wellness and their ability or interest to actually change something in the wellness. So that's for the preventive healthcare, let's say. And there, if you can call that a digital twin, we mainly try to get a digital twin of their mindset, knowing how to influence their behavior to support their lifestyle changes, for example. But I think also Peter had a good example for the use of digital twins for diabetes.
Yes. I happily explained that, and I would again like to point also to the chat sections and the Q&A sections where I have pasted some pointers for what I'm about to explain. I pasted there some URLs for two projects. The one is the Eindhoven Diabetes Simulator, and the other one is called DiaGame. In a nutshell, what we do there is we have a metabolic digital twin where we can simulate the insulin production of a human body. And there you have essentially a number of important parameters that are highly personal and also dependent on food intake. So in those projects, we are now making steps towards not just doing offline analyses using such simulators, but also connecting them to data that is coming on a continuous basis from all kinds of sensors when people just live their lives at home. Because that's indeed what you are confronted with, in particular if you have diabetes type 1, it's for your life. So if you can equip then good predictions on when certain rises in insulin are going to take place, you can be much more precise on the treatment level. So that's, okay, so that's about that. And I had pasted some pointers for those who want to read more about it. I would also like to make more at the high level a distinction between these digital twins of the patient on the one hand, and other work where the digital twin is the one of the hospital. A brief mentioning was made about that, I think, also by Monica. But indeed, also other projects do that, like simulate throughout specific hospital configurations, what are the consequences of moving beds towards certain wards and what have you. So then finally, I would like to clarify also why we took those specific examples as surveyed by Monica, these projects are really from the formally affiliated BDVA status, and they're not meant to be discriminating at any rate. They're just, since the BDVA is so inclusive, representing the whole ecosystem. And certainly all of the BDVA partners also have a number of other projects that we happily share further information about in the chat or via other means. So far from my side.
Thank you, Peter, Johan, and Monica. And before we move to the last section, I would like to remind also for the participants from all the sections, importance, key areas, technical and technical challenge, also the enablers. If you think we have missed anything from the workshop or for the survey and you think it's important to address, please put it in the chat box so that we can have a look.
Tiblet, one more
Yes.
question came in just now.
Yeah.
I mean, I picked it up just now.
Okay, go ahead.
So let's perhaps also handle that. Thanks for Amalia for helping me with that. The question is, are there any use cases that use federated learning techniques? And also, there's a more practical question, which perhaps we better take in the chat. But who is ready to answer, perhaps Monica, that within Deep Health or other projects, federated learning techniques are used?
Yes, in the Deep Health project, I think we have 2 of them using federated learning. They are exploring the use. There are also another one. We are also considering split learning, which is a similar technique, not to have to share data, since, as we have commented, both federated learning and split learning have overcomes the challenge of how to move data from the hospital premises, since the considerations of privacy and some of the times policy limitations to move the data. I can ask for the chat, since I don't have the information right here. Those cases are iterated by the University of Torino, but I can provide now after just the maybe a contact or whatever, more information about it. And so this is what I can say at this moment.
Okay,
I can search for it and provide information. I don't have all the information right now in my mind.
Yeah, sure. Thanks, Monica. So then I suggest we go to the last section, which is the conclusions. Peter will be concluding, give us the conclusion of the paper, basically. Yeah. Peter, the floor is yours.
Thank you. So with the conclusions, I first want to make a big disclaimer that in a moment I will give like a key policy recommendation. And the disclaimer is then that this is aimed to be very clear on a very high level top priority. And it's not meant to say that this is the only lesson learned from the paper, because indeed, if we look at the structure of the white paper, we have 7 topics, and all of them have their own kind of mini conclusions embedded within the white paper. And the key recommendation I will give will sometimes fully ignore these, while they are actually quite useful looking at their specific context. Like, one question was, what's the importance of AI in healthcare? And that is separately handled with a sub-conclusion in the white paper. The second one was, what are the key areas in which AI has the most potential? About that, I think Johan has shared with us an excellent mental model, kind of taxonomy, to help us reason about those key areas. And also he has presented us with numbers on what the community has told us as being their view on the key areas from the European perspective. Also then Ernestina has talked about what are the technical challenges that are major, and she also shared with us the challenges of non-technical nature. Then we heard about enablers and facilitators for future uptake. And Monica has told us about the success stories. So the question then that could remain is, what are the specific tasks for AI expected to be successful in the future? I think that also partly relates to the discussion that we've had with you, where also actually the one on the digital assistant is quite related. but please do look at the white paper for a more comprehensive look at that. The white paper is available at the BDVA downloads section. We've also been sharing that in the chat. But on the next slide, then, let me make a humble attempt towards making one key policy recommendation that is basically supported by all of the methods applied, so literature study, workshop, and survey across the different questions. One thing was like really something that was a central theme, and that is the availability of data. Now, as Jorge has rightfully stressed many times, this is certainly not only a technical matter. And also Ernestina has given the example of national laws prohibiting data to leave the country in which the data is produced. Now, we could be negative about this and say, well, then we're doomed. We're never going to have large-scale data sets within the EU. But fortunately, future is brighter. But then let me take one by one the implications of what I just said. What do we want to give as advice to the policymakers at the European level? At the technical level, please do ensure that you enable projects in which data will be better integrated, better labeled for systematic AI applications. With that, keep in mind that often data is only labeled for a very specific purpose, and then metadata is often lacking, enabling the automated interpretation, automated merging of such a data set with another one. This is a major issue, and it's often also caused by the very strong focus of specific projects to only solve their problem and not think about secondary use of the data. Within the technical area still, privacy and security has been mentioned. But again, about a bright future, in the white paper, you can read about techniques in which AI is actually the enabler for solving privacy and security problems. In particular, we explain there the use of specific networks that produce synthetic data out of highly sensitive data. And we advise to essentially enable more projects in that area because that really fundamentally allows the public sharing of data without the typical privacy barriers. Another approach, fully orthogonal to this, is to work with the real data. But then, instead of sending that data out for analysis by a data scientist, let the algorithm travel to the data. So about that, we've talked about federated learning, and also that is really, especially in a European setting, given the current legislation, a way forward instead of saying, we're doomed, we cannot apply AI. Then if we take the liberty to also look at the regulatory aspects of promoting data availability, we especially encourage projects in which there are clear and fair rules to all innovation stakeholders. I remember in Valencia a discussion with the medical participants where they honestly disclosed that they lacked the incentives to participate in innovation projects because they felt not treated right by big industrial players that would say, let's go in a research project, we build technology using your data, you get funded to participate in the project, but whatever comes out of this is ours. And we felt that this was just one example, one clear story of a bigger pattern where when we engage to innovation projects, we should have fair rules for all the innovation stakeholders such that their incentive is there and they really want to invest their time genuinely. Then 2 specific action points: sharing template copies of successful collaboration contracts. And second, invest more in large-scale pilots that bring together public and private partners. These were the key recommendations. Final remark, kind of a disclaimer again. Of course, the samples we took were limited. In particular, in the workshop, we had 63 participants and only 1 in 4 was of a hospital. In our future work, we welcome very much medical stakeholders to join the BDVA stakeholder community and then strengthen their participation rate such that in the future we can perhaps give even more solid results based on also their views. Thanks a lot. Then, about acknowledgements. On the left, you find actual contributors to the white paper text. On the right, you find also names of people who have been contributing specifically to the use cases reported. But then finally, I would like to acknowledge again also the people who have been filling out the survey. 131 individuals of the BDVA ecosystems have invested precious time in giving high quality results to that survey. And moreover, 63 people have joined that Valencia workshop. And ultimately, we could not name all of them, but we certainly strongly appreciate their participation because we're so highly dependent on them.
Yeah. Thank you, Peter. So this basically ends our presentation. We still have some time for questions if they are still there. Until you prepare the questions, I would like to bring the Menti one more question. Sorry. So yeah, we would like to ask you if you can answer this question. So the question is, which topic within health AI needs additional European funding, apart from what we're discussed basically? And you can go to menti.com and use the same code. I'm hoping you see my screen. Yeah. It's a free text, so it may take some time. In the meantime, Peter, do you see any question coming apart from the ones that are answered? Yeah, I see data sharing, inclusiveness, that's very important. Prevention-related actions, decision support systems, explainable AI indeed. Trustworthy and evidence-based, IT infrastructure, telemedicine, yeah. Data science education, yeah, for medical, for the health practitioners, very important. Okay, yeah, please keep on writing. So we will take this, yeah, we get a summary out of it and consider including it also in our work within the health subgroup in BDVA. Do we have any question, Peter, Monica, or others?
Very practical ones on URLs of project and so. So I propose we handle that one in the chat.
Offline, yeah. Okay, perfect. All right. Thank you very much for all the participants and also for the presenters. And again, thank you so much for all the contributors for this white paper. So yeah, this ends our presentation. As said, the session is recorded, and also we have the slides will also be shared by BDVA later. Thanks also Martina for facilitating this session. Thank you so much, and bye-bye.
Thank you. Bye-bye.
Thank you.